Hi everyone, we're going to talk today about linear versus nonlinear functions. Last time we spoke about what a function is. Now we're going to delve deeper into that and talk about types of functions. So to determine if a function is linear, let's start with this. What word do you notice in linear? Line. So anytime you have a linear function, that just indicates that it represents some sort of line. So the graph of your linear function is going to form a straight line. When you have a table, it is going to have a constant rate of change. Your equation is going to be in y equals mx plus b form. So let's look at this example over here. We have a table that we need to fill out. They give us an equation. And then after we get our whole table, all of our x's and y's, we're going to plot them and determine based on those three things, the equation, the table, and the graph, if our function is linear. All right, so let's start with -2. The way we're going to fill out this table is we are going to replace the x with -2 and solve. So -2 times -2 is 4, plus 1 gives us our y value of 5. Our next x value is -1. All we're going to do here is plug in all the x values and solve for it using PEMDAS. -2 times -1 is 2, plus 1 is 3. Zero, we plug in 0 there. -2 times 0 is 0, plus 1 gives us 1. Plug in 1, -2 times 1 plus 1. -2 times 1 is -2 plus 1 gives us -1. Last but not least, we have 2. -2 times 2 plus 1. -2 times 2 is -4, plus 1 is -3. So now we have completely filled out our table. Now we're going to look at the x column and the y column to figure out where to plot everything. So our first point is -2, 5. So we go over to -2, up 5. And then we keep going. -1, 3, 0, 1, 1, -1, 2, -3. We've plotted our lines, so we're going to connect them with arrows on the ends. And we're going to write the equation on the line. So y equals -2x plus 1. So to figure out if this function is linear, what we're going to do, I'm going to write all three explanations, the equation, table, and graph. You can honestly just pick one, whatever you're most familiar with, but I'm going to show you all three. So we can tell it's a linear function. If we look at the graph, it forms a straight line. We're going to say graph. Line. If we look at the table, The table we define, if we look earlier, we figure out if a table is linear by looking at the rate of change, if it's constant. So let's look at what each of these is going up by. Look at your y's. Looks like every single y value, to go from 5 to 3, we subtract 2. To go from 3 to 1, we subtract 2. 1 to -1, we subtract 2. 1 to -3, we subtract 2. So on the y's, it looks like we're set. Let's look at the x's. -2 to -1, we're increasing by 1. -1 to 0, we're increasing by 1. 0 to 1, we're increasing by 1. 1 to 2, we're increasing by 1. So what this tells us is, since our y's are going up by the same number every time and the x's are going up by the same number every time, our table tells us it's linear because the table has a constant rate of change. And the equation has to be in y equals mx plus b form. So if we look back to this equation up top, it looks like it's in y equals mx plus b form. So that's why this equation is linear. There's no exponents. There's nothing funky going on. It's in y equals mx plus b form. Awesome. So now let's figure out what a nonlinear function looks like. It is the complete opposite traits of a linear function. So our line, our graph, is not a straight line. Our table does not have a constant rate of change. And our equations are not in y equals mx plus b form. So that may be things like having a variable in the denominator, having an exponent on that variable, anything that's not in y equals mx plus b form. So let's look at this table here. Let's fill it in like we did last time. Everywhere we see an x, we're going to plug in whatever x value it tells us to plug in. So -2 squared plus 1. 2 squared is 4, plus 1 is 5. -1 squared, plug it in. 1 plus 1 gives us 2. Zero squared plus 1, 0 squared is 0, plus 1 is 1. One squared plus 1, that's 1 plus 1, which gives us 2. And 2 squared plus 1, 2 squared is 4, plus 1 is 5. So now, let's plot these. So we have -2, 5, -1, 2, 0, 1, 1, 2, and 2, 5. Label it. Now we're going to figure out if this is linear or nonlinear. So if you look at the equation, you look at the table, you look at the graph, and you connect it back to the rules we had before, you will determine that our function is nonlinear. because if you look at the graph, it's not a straight line. If you look at the table, we're going to look for that constant rate of change again. We're going to see if it has one. So if you look at the y's, to go from 5 to 2, we have to subtract 3. To go from 2 to 1, we subtract 1. 1 to 2, now we're going up 1. 2 to 5, we're going up by 3. So we know just by these numbers here that there's no constant rate of change. First we're going down 3, then we're going down by less, then we're going up by 1, then we're going up by 3. We're all over the place here. So there's no constant rate of change. I'm going to use ROC for rate of change because I'm running out of room. And then last but not least, we're going to look at this equation up here. The equation has to be in y equals mx plus b form. And by a quick look at it, you may think it is in y equals mx plus b form. However, look at this little exponent. Remember, the rule tells us that we can't have exponents on variables. So equation is not in y equals mx plus b form, and that's because there's an exponent on the variable. All right, and that is how we determine a linear function from a nonlinear function. Have a lovely day.